Hello all. In this lecture, we will see about different types of database users. Then also will also see about the advantages of using this DBMS, and also we will see a brief history of DBMS. So first of all, we will see the different types of users of a database. So database users can be classified into two. First one is actors on the scene. That is, those persons who will be using this software, who will be using this database, will be called as actors on the scene. And there is a second type of users, they are called as workers behind the scene. Those people actually make the DBMS software. Workers behind the scene makes the DBMS software and also the various tools that are required for the DBMS package. So we'll first of all see actors on the scene. So these people are those who use and control the database content and those who design, develop and database applications. So actors on the scene are the people who will control the database content. If we consider a small database, personal database and all, those people, a single person will be responsible for defining, constructing and manipulating the database, and there won't be any data sharing and all if it's a personal single user database. But in the case of huge databases, there will be different people who will be involved in this database creation and all. So in the so first case, the actors on the scene, people will be the persons who will be controlling the database content. They will be designing, developing, and maintaining this database application. So some of the actors on the scene are, for as shown as database administrators. Then we have database designers. Then we have end users. There are various kinds of end users. And the fourth type of actors on the scene is system analyst and application programmers. We call it as software engineers or software developers. So actors on the scene are the people who will be using this database, who will design, develop and maintain some database. So these are the various kinds of actors on the scene: database administrator, database designers, end users and system analyst and application programmers. So you will see in detail all these users. Then the second type of users are the workers behind the scene. So these people are won't directly use this database. These people will be developing the DBMS software and also the related tools required to run that software. So if it is an SQL package or MySQL, so those people who will be developing that database, that software, that MySQL software, are known as the workers behind the scene. So we may require some tools, additional tools to use that DBMS. So those people who will be developing those tools are also falls under this category known as workers behind the scene. So some of the workers behind the scene are DBMS system designers and implementers. Then we have tool developers, operators and maintenance person. So we will see all the type of users. First of all, we will see actors on the scene. The first type of actors on the scene is database administrator. So he is a person who will be the chief administrator to oversee and manage all the resources. Here the resources means a database. So database administrator is a chief administrator. He will be a person who will be for the managing the database itself. Okay. So database, we call him as a database administrator. He is the head of this database software. So he'll be authorizing access to the database. So database administrator, if you take an organization, he will be the person who will be authorizing access to the database. He will decide which all persons to be authorized to use the database, and he will be coordinating and monitoring its use. He'll be monitoring the use of different people, and he will be the person who will be acquiring software and hardware resources that are needed to run this DBMS or that software. Then he is also the accountable for problems such as security breaches and poor system response time. If there is if some problem occurs in the security of the system, he will be the person who will be responsible. If you take an organization, database administrator kind of job is a very good job, because everything is automated. He needs to just to create backup, or he needs to just monitor all. There are all automated tools to do all these things. But if some problem occurs in the database part, he will be the sole person responsible for that, and he will be fired from the organization. So he is accountable for problems for this. If something occurs in the security, or some poor response time, any problem occurs, if there is a problem, if he forgets to take the backup, if there is some problem, the person who will be fired first will be the database administrator. Then he may have assistants also. Database administrator can have several assistants also. Then the second type of actors on the scene is database designer. So he is the person who is responsible for identifying the data to be stored in the database. So he will be creating the database. He will identify what all things that are need to be stored in the database. He will choose the appropriate structures to represent and store this data. He will identify which all tables will be required. Then he will enter the data elements in the software. He will decide what all elements should be there inside the database. The main thing he should do is he should communicate. He should communicate with all database users in order to understand their requirements. So in order to understand the requirements of all users, he will communicate with all type of users, so that he will get an idea on what all data that is to be stored in the database. And he will be the person who will be create and design and he will create a design that meets his requirements, and he will be designing that software, and he will interact with each potential group of users and develop different views. We have already seen the previous lecture, there will be different views of the same database. A bank clerk will have a different view. An ordinary user will have a different view of the same banking software. So he should interact with each potential group. So he should interact with managers of the bank. He should interact with the clerks of the bank. He should interact with the ordinary users of the bank, so banking software. And he should create views so that all those requirements are met. And finally, he should prepare a final design which will support all the requirements of all these user groups. So that is the role of this database designer. Then the third type of actors on the scene is end users. We have mainly four types of end users. We will see each one. So these people whose jobs require access to the database for querying, updating and generating reports. So these people will be the actual users of the database. They will be querying. They will be asking some, if you go to a library, library, you will be asking whether you will be searching for a particular book, or if you are using an airline reservation system, you will be searching for a particular flight. So those type of users are known as end users. So they will be querying, they will be updating, they will be adding something to the database, they will be generating this report. So all these will fall under the category of end users. Even the bank clerks are end users, or the of managers, bank managers, or the faculty of, if it's a college automation software. All these people will fall under the end users category. So in end users itself, we have four types of end users. First one is casual end users. So these people, if you consider a banking software, we people can be called as casual end users, because we will simply go to an ATM and we will check the balance, or you will log into your net banking and you will check the balance, or you will retrieve some reports, generate some reports and all. So casual end users occasionally access the database, but they may need different information each time. So when you log into your net banking, you will once you will be asking for the last mini statement. You will be asking for a last 10 transactions, or sometimes you will generate a report like last financial year full transactions, or sometimes you will just simply inquire the balance. So occasionally they will be using the database occasionally, and may need different information each time. Then they will be using a sophisticated database query language to specify their request. So we will be using a query language. So we won't be aware of the what all is happening inside that. We will be simply querying and we will be getting output. Okay. So this end users can be middle or high level managers also, and also occasional browsers can also be considered as casual end users. Then the next type of end user is naive or parametric end users. So this is the main portion of the database users. Their main function is to constantly query and update the database using standard types of queries and updates. And we call that set of queries and updates as scanned transactions. So if you take uh, a clerk in a bank, they are known as naive or parametric end users. Or if you take a reservation system, airline reservation system, or if you take a railway reservation system, that clerk who is reserving the tickets or booking the tickets are known as naive or parametric end users. Because they will be constantly querying and updating the database. They'll be giving some transactions, and based on those transactions the database will make its updations. So these are known as naive or parametric end users. So bank tellers, reservation agents for airlines, hotels, car rental companies, all these fall under this naive or parametric end users. Then the third type of end users are known as sophisticated end users. This include the engineers, scientists, business analysts, and others who thoroughly know the capabilities or the facilities of this DBMS. They are, they are familiar with all the functionalities of the DBMS, and they try to develop their own applications to meet their requirements. So if you are a scientist or an engineer, you might require, you know what is a DBMS software and you know the functionalities of that software. And if you want to develop something related to your personal project or product, you try to implement your own applications. Then you will become a sophisticated end user. Okay. Then the fourth type of users are known as standalone users. Those people who will be making this personal databases based using some ready-made packages are known as standalone users. For example, if you are building a tax software, so to calculate your own income tax and all, that type of users are known as standalone users. So he will be using a personal database. He will be maintaining his own database. He will be adding all those details. He will be creating the database, and he'll be using it for his own personal use. Then those users are known as standalone end users. Okay, example calculation that software. If you are making one, then it is known as standalone end users. So these are the four types of end users. Then the fourth type of actors on the scene are known as system analyst and application programs, or together we call them as software engineers. So system analyst, we'll see system analysts are the people, these people will be working in the organization. So these people will determine the requirements of end users, especially from the naive and parametric end users, and they develop some applications. They develop some applications or develop some specifications to solve those standard canned we have already seen. So those naive and parametric end users require some canned transactions that are to be executed. So the system analyst will find out which all transactions are need to be processed, and based on that they create this database and all. So these people are known as system analysts. Then we have another group of people known as application programmers. These people will be developing the application program to interact with the DBMS or the interact with the database software. So they implement the specifications specified by system analyst into programs so that these programs can be debugged, tested, documented, all those things can be done. So analysts and programmers are together referred to as software developers or software engineers. So these are the four types of actors on this. So first one is database administrator, then we have database designer, then end users, and in end users we have four types of end users, and the fourth type is system analyst and application programmers. Together we call them as software engineers or software developers. Then another category of people are known as workers behind the scene. So these people actually develop the DBMS software and the tools. So they design, development and operation of the DBMS software and the system environment is done by the workers behind the scene. So we have different workers behind the scene. First one is DBMS system designers and implementers. These people actually design and implement the DBMS module. So if you want to develop an Oracle software, so those people who will be designing and implementing the modules in the Oracle software will be called as DBMS system designers and implementers. So they will develop some modules for implementing the catalog, query language processing, interface processing, accessing and buffering data, then controlling redundancy. All these modules will be included. For data recovery, security, all these packages will be designed and implemented by this first workers behind the scene, and we call them as DBMS system designers and implementers. Then we have tool developers. That is a second category of people, workers behind the scene. They actually design and implement tools, and these tools are optional tools. So those optional tools will be developed by this tool developers. These are software packages that may or may not be included in the DBMS software. So maybe database design tools will be there, performance monitoring tools will be there, natural language or GUI tools will be there, prototyping tools, simulation, test data generation. Like that, there will be different kinds of tools which will be used by the DBMS. So these DBMS software plus tools will whole become the whole DBMS software. If we consider a DBMS software, we will have the basic functionalities DBMS software. Additionally, there will be optional tools that will be included, and those tools will be developed by the tool developers. Then the third type of workers behind the scene are the operators and maintenance personnel, or we call them as system administration personnel. They are the person responsible for running and maintenance of hardware and software environment of the database system. So these are the various workers behind the scene. Next, we will see some of the advantages of using the DBMS approach. So there are several advantages of using this DBMS. So we'll be comparing these advantages over file system, over the traditional file system. So first advantage is controlling redundancy. We will see each one separately. Then second is restricting unauthorized access to data. Third is providing persistent storage for program objects. Fourth is providing storage structures for efficient query processing. Then fifth, providing backup and recovery services. Sixth one is providing multiple interfaces to different classes of users. Then seventh is representing complex relationships among data. And eighth, enforcing integrity constraints on the database. Ninth, permitting inferencing and action using rules. So these are the main advantages, and additional implications are there. We will see that later. So first advantage is controlling redundancy. So redundancy is an important thing that is to be controlled. So if we keep redundant data, so if we imagine that there is no software in our college, so what happens is we have to keep the student records, student details, your name, address, phone number, everything in paper files, and it will be stored. One copy will be stored in the office, college office, another copy will be stored in the department. Like that, there will be several redundant copies of the same data. Since we have a campus management software, what happens is you people will be entering all this data once in the software, and this software can be accessed by the office people or the department or students or parents. Anybody can access this data. So if we use this database, we can control that redundancy. So in earlier days when we use file system, so different applications will be using different files. So if you want student records, student details, and if I want to run an application program, I will create my own program and I will create my own files. Then another person who wants the same data will create his own file and own programs. So the problem is there will be redundant information everywhere. So if there is redundant information, what happens is there will be inconsistent data. So controlling redundancy means storing the same data multiple times leads to several problems. So first one is duplication of effort. So we need to store different data. So for example, if do not have any database, what happens is you will have to write everything in paper, store it in one copy in department, one copy in PTA, another copy in society, another copy in college office. Like that, there will be different copies, and there will be duplication of effort. And storage space itself is wasted when the same data is stored repeatedly. Then files that represents the same data may become inconsistent. There will be inconsistency because if you change the address, your if your student has changed his address, what happens? You have to change it in the department, you have to change it in the college office, you have to change it in PTA. Like that, wherever that data is there, you need to change it. But if you are using a database, there will be a common database. If you change the database, that change will be reflected by all type of users. So that is controlling redundancy. So we can control that redundancy if we are using this database. So you'll see about this redundancy and all when we learn this database design normalization. We will see what are the problems with this redundant information. Second advantage is restricting unauthorized user access. So there will be multiple users using the same database. So if we try to give every person authorized, if you authorize every person to access the whole information, then it's not a good thing. For example, if we have a college database and if you people are given modification or updation access to the database, so you people will be modifying your sessional marks, so you can modify your in, uh, your series marks or your assignment marks. You can modify everything. So in order to prevent that, we need to restrict that unauthorized access. So database provides that restriction. Only authorized persons are allowed to access in a database, and we can provide that security mechanism. So some users may only be permitted to retrieve data. So if it's a college database, you people will be able to only retrieve the information. You may not be able to edit your student records, or you may not be able to edit your marks. So some others will be allowed to retrieve and update the data, and we can provide security and authorization subsystem also, and we can provide security and we can give some authorization also. Not everybody can access your personal details. Only authorized person will be able to access that your personal details. Like that, we can restrict that access. So this is another advantage of using Dbms. Then another third advantage is providing persistent storage for program objects. So when object-oriented program came, we need to provide persistent storage for program objects and data structures. So if you consider this object-oriented system, we have already, if you are familiar with object-oriented languages, say C++ or Java, they will be using these objects, and those objects will be discarded as soon as the program terminates, unless the programmer stores them in permanent files. So in order to store those objects in somewhere, we provide the database usually provide this persistent storage mechanism. So it is mainly applicable to object-oriented database and also object relational databases. So we can provide persistent storage. That is, those objects, even after the program is terminated, all those data can be stored in the database. So when a need arises, those data can be retrieved later by the programmer. So this is the advantage of using a DBMS. Otherwise, if you are using files, whenever that program terminates, all that persistent, all the data, object data will be lost. Then fourth advantage is providing storage structure and search techniques for efficient query processing. So database provides capabilities for efficiently executing queries and updates. So there will be a the DBMS provides a good structure. We will be learning about indexing, hashing, B plus tree, B, all these things are there. Those using those data structures, we can store all those information in the secondary device, like your hard disk or anywhere in the secondary device. You can store all these things. So whenever you want to retrieve some information, this DBMS can easily retrieve all those information easily, because we'll have some mechanism, indexing mechanism and all. So efficiently executing post queries and updates is possible if you are using this DBMS. And additionally, we have buffering and caching module also in the DBMS. Then also query optimization techniques are also there in our DBMS. We will learn about query optimization in later lectures. Then another advantage is providing backup and recovery mechanism. So DBMS provides this facilities for recovering from hardware or software failures. So failures can occur in our hardware or software. So if some failure occurs, we need to restore some data. So we need to recover our data. You will be using your WhatsApp and all. When you shift your phone, or if your phone gets damaged and if you want to use it, your WhatsApp in your new phone, it is possible to recover everything, because you will be backing up all those data. So in DBMS, there is a backup and recovery mechanism. So even if some failure occurs, we can recover from the software. So this backup facility will be there. Then another advantage is providing multiple user interfaces. So different types of users will be there. There will be various variety of users. So there will be casual users, there will be application programmers, there will be designers, database designers, like there will be different kinds of users. So DBMS software provides different interfaces for these different kinds of users. Uh, a casual user may require a GUI interface. A parametric user may require some other kind of interface. A database designer may require some other kind of interface. All these kind of interfaces are possible in a DBMS. So these are some examples. Query languages for query casual users, programming language interfaces for application programmers. It may be forms and command codes for parametric users, or menu-driven interfaces and natural language interfaces for standalone users. So various kinds of interfaces. How to interact with this database, we require some interface. So that interface can be of different variety. Then another advantage is we can represent complex relationships among data. So if we consider data, there will be interrelationship between this data. The data will be related, because if we take a student file, and if there is another grade report file, there will be some relationship between these two different tables. So if we want to represent those relationship between those two tables, those kind of relationships can be represented in a DBMS. Then another advantage is enforcing integrity constraints. So most of the database have certain some integrity constraints that must hold for any kind of data. So it has capabilities of defining and enforcing these integrity constraints. That is, integrity constraints, we will be studying it later. For example, I will just mention an example. For example, if it's a college software, if you are entering a student data, we will mention that admission number should be unique. Then that uniqueness, that admission number is unique, that is a property, and that is known as an integrity constraint. We call it as a uniqueness constraint. So like that, there will be different kinds of constraints that will be enforced on the database. Or we can enforce an constraint like the phone number should be numbers only and it should contain 10 digits. Then that is another type of constraint. So such kind of constraints can be enforced when we use this database. Then the ninth advantage is permitting inferences and actions using rules. So it provides, so the DBMS provides capabilities for defining deduction rules for inferencing new information from the database facts. That is, if we are storing some kind of information in different tables, we may need to infer something. For example, I want to infer the average age of all the students of the college, then it is possible. So such kind of inference rules, deductions are all possible. Or I want to calculate some average of all the CGPS of all the students of the college. Like that, we can infer or deduce by applying some rules onto the database. So these type of functionalities are available in DBMS. So these are the advantages of DBMS. Additionally, we can mention a few more, like potential for enforcing standards. That is, if you are using database software, it will have additional implication for the organization. So first implication is potential for enforcing standards. So if we are using a database, then there will be a standard in the whole organization. The whole organization will be following a single approach. And if we consider the college, all the college departments will be storing the same kind of data. They will be storing, if it is a date of birth, so date of birth format is dd slash mm slash yyyy. So all the departments will be following the same format. So that is known as potential for enforcing standards. So we can enforce such kind of standards for the whole organization as such. Then second advantage, another implication for an organization is reduced application development time. So if we are using database, then it will be easier to develop applications or softwares using this software, DBMS. So if you need DBMS for our software that is to be developed, then it will reduce if you are using reduce the application development time if you are using a DBMS. Then third advantage is flexibility to change data structures. There is flexibility if we are using the database. So that is, if we want to change the data elements in the database, or if we want to change the data structure, how it is stored in the disk, all those things, or if we want to change the hard disk itself, it is all possible because there is flexibility to change everything if you are using a database. If you are using files, it will be a big problem to change the data structures and all. So here we can have that flexibility to change everything. Then another advantage is there will be availability of up-to-date information if you are using a DBMS. So if you consider an organization, the organization will have an up-to-date information. If you consider the college, since everything is in the software, if you want to get the total number of students that are admitted in the college, we can easily query the database and get the up-to-date information. So the current information, the up-to-date information will be available if you are using a database approach. Then the last implication for an organization is economies of scale. As DBMS permits consolidation of data and applications, there will be waste. There will not be any wastage of storage or wastage of data processing personnel in the organization. Everything will be stored in the database. We need not have multiple files and all. If they have multiple files, then we need different personnels to change all those files and all. So here organizations will require lesser money in terms of money. If we are using database, less amount of money will be required to maintain this database and all. So overall cost of operation and management will be reduced if you are using database. Next, we will see a brief history of this database application. So earlier database, initially in 1960s and 70s when database was developed, we were using hierarchical network models, were introduced in mid 60s, and it dominated through 70s. We need not go into what is hierarchical and network model, and we'll simply mention that hierarchical model, it's a model which has a tree-like structure. That is, if you consider an organization, the principal will be the head, and below the principal there will be different head of the departments, and under the head of the departments there will be different faculty. Like that, there will be a tree-like structure. Similarly, data will be organized in a tree-like structure in hierarchical database. If you consider that network model, it's like a graph-like structure. Everything will be connected. All those data will be connected there, here and there. Then it is known as network model. So those type of databases were available in 1960s, hierarchical databases and network databases. Then came the relational model based systems. It was introduced in 1970. It was actually introduced by IBM, maybe IBM in early 80s and all. This came. This was success those days. Code, EF Code boys, and all those people were behind this relational database kind of thing. Then after that, when object-oriented languages came, object-oriented databases came, object-oriented database management systems came. ODBM was introduced in late 80s and early 80s, 90s. It is to cater these databases were used to cater the need of complex databases processing in CAD and other applications. Then after that, object relational databases came. That is object oriented plus relational model. So it was known as ORDBMS came. Then additionally, extended relational systems add further capabilities for multimedia data, XML, and other data types. Then later on, data on the web and e-commerce applications came. So we need to store web content, all e-commerce content. So web contains data in HTML with links with other pages. So those e-commerce sites all require this XML kind of thing. So scripting languages came. So for all these applications, several other databases came. Then new functionalities was added to the DBMS, like for scientific applications. If you want to store large amount of data for scientific experiments, in physics experiments, human genome experiments, or if you want to study the protein structure. So if you want to study the structure of this COVID-19 virus and all those are known as scientific applications. For those kind of applications, several databases and all came. Then choose for this XML extensible markup languages, then image storage and management, images type of databases were needed, audio and video data management, then data warehousing, data mining, then spatial data management, where location of data, weather information, maps, geographical information, all these things are known as spatial data management. Then time series and historical data management. If you want to calculate the or to check the time series data, like the stock market prediction, all these are time series data. So for those things, or daily sales and monthly gross national product or GDP, all these are time series historical data. So for that, some databases were developed. All these functionalities were added to the DBMS software. And later on, big data storage systems and NoSQL databases came. So NoSQL is not only SQL, other databases are quite like we will learn about this NoSQL and all in the last module. So next, when not to use database. So we should not use database always. Certain cases are there where we cannot use database, and there are certain constraints for this DBMS. So first thing is based on cost. Cost of using a DBMS it's an inhibitor to use this database. First inhibitor to use this database is cost. So if we consider the cost, high initial investment in hardware, software, and also training is required if we are using a DBMS. So if we are not going to invest too much on this hardware, software, and training, then we should not go for this DBMS. And also there is overhead for providing the security, concurrency control, recovery, integrity. All these are some of the functionalities that are to be supported by the DBMS. So if we want all these support functionalities, then the cost will increase drastically. Okay, so if we are using a small application, then we do need not go for that DBMS. If we are using some customized database applications, we need not buy this complex DBMS software and all. We can simply use file system itself. If we have simple, well-defined database applications that are not expected to change at all, then we can go for files itself. We need not buy this DBMS at all. And if there are stringent real-time requirements, if we are using real-time systems, then will not go for database, because if we are running some real-time, like if we are monitoring the uh, rocket launching system, those cases we should not go for database, because we need real-time monitoring of that system. The database will become is an overhead and it will be slow up the process. So we should not go for a database in the case of real-time requirements are needed. Then for embedded system also we will not use this database, because embedded system have limited storage capacity. DBMS will require huge storage capacity. And if there is no multiple user access to data, then also we need not go for this database. So that's all about introduction to this DBMS. So this is the reference 6th edition and 7th edition of El Master and Navate. Thank you.